क्वांटम मैकेनिकल मॉडल ऑफ एटम। इस पे हम क्वेश्चन सॉल्व करेंगे लास्ट 5 years में जो भी पूछे हैं। इसमें क्वेश्चन फर्स्ट है, टू इलेक्ट्रॉन्स ऑक्यूपाइंग द सेम ऑर्बिटल्स आर डिस्टिंग्विश्ड बाय। अगर दो इलेक्ट्रॉन्स एक ही ऑर्बिट में अगर है तो हम उसको डिस्टिंग्विश कैसे करेंगे, उसका डिफरेंस कैसे पहचानेंगे, तो बाय द स्पिन क्वांटम नंबर। योर करेक्ट ऑप्शन इज बी फॉर दिस। Question number 2. Maximum number of electrons in a subshell is given by expression. We can calculate it by the formula 2 into bracket 2L plus 1. That is option number B is correct for this question. Question number 3. The correct set of first three quantum numbers for the unpaired electrons of chlorine atom is. As we know that chlorine has the atomic number 17. Then we can write its electronic configuration as 1s2, 2s2, 2p6, 3s2, 3p5. As the last electron enters in the 3p orbit, hence we can write from that n is equal to its principal quantum number becomes 3, azimuthal quantum number L is equal to 1. And for the L, if it is L is equal to 1, how many values of M is there? There are 3 values, plus 1, 0 and minus 1. If we see these all numbers, according to that, if we check the options, then in that option number B is correct for this. 3, 1 and plus 1. Question number 4. How many values of magnetic quantum number are possible for each value of azimuthal quantum number? We can calculate it by the formula 2L plus 2. That is option number B is correct. Question number 5. What is the maximum number of electrons accommodated in a subshell having the azimuthal quantum number L is equal to 2? If azimuthal quantum number L is equal to 2, then it means it is the d orbit. As we can see, in the d orbit there are 5 blocks, and in each block 2 electrons can be contained. Hence the total electrons that can be accommodated in the d orbit are 10. And for this question, option number A is correct. Question number 6. What does the magnetic quantum number describes? Magnetic quantum number describes orientation of an orbit in the given subshell. If we see the options, then in this option number C is correct for this. Question number 7. Which of the following principles decides that an orbital can accommodate maximum 2 electrons with opposite spins? एक ही ऑर्बिट में 2 इलेक्ट्रॉन्स एंड उसके स्पिन अपोजिट होती है। ये प्रिंसिपल किसने, कौन से, अकॉर्डिंग टू कौन से प्रिंसिपल ऐसा कहा गया, ये पूछा है आपको इस क्वेश्चन में। तो इसका करेक्ट आंसर है पाउलीज एक्सक्लूजन प्रिंसिपल। ऑप्शन नंबर बी इज करेक्ट आंसर फॉर दिस। Question number 8. What is the total number of unpaired electrons present in observed electronic configuration of chromium? As we know, chromium's atomic number Z is equal to 24. And if we take the electronic configuration of that, its outermost electrons will present in 3d5 and 4s1 orbits. Then if we count the total number of unpaired electrons, then we get the 6. That is option number C is correct for this. Question number 9. What is the number of electrons present in D subshell in +1 oxidation state if its atomic number is 24? As you can see the electronic configuration, if any element's atomic number is 24, then its electronic configuration will become 3d5 and 4s1. As it's in d orbit, how many electrons are present, it is asked, then 5 electrons are there. Then option number B is correct answer for this question. Question number 10. What is the number of unpaired electrons present in d orbit of chromium to have extra stability? If we see the electronic configuration, then we get the 3d5 is in the last orbit and 5 electrons are present in the d orbit. According to this question, if we check the options, then option number A is correct answer for this. Question number 11. Identify the terms used for species having same number of electrons. Its option number A is correct for this isoelectronic. In that only we are discussing about the number of electrons. Question number 12. What does the principal quantum number describes? If we check the principal quantum number of any element, then we get the its size of orbit. How many orbits are present in that, and according to that we get the size of orbitals. Then option number B is correct answer for this. Question number 13. What is the value of magnetic quantum number for electron having principal quantum number n is equal to 1? अगर principal quantum number n is equal to 1 है, it means which orbit? It is s orbit. And for the s orbit, if its magnetic quantum number is 0, then option number A is correct for this. Question number 14. Which from the following rule principle states that no two electrons in an atom can have the same set of four quantum numbers? It is according to the Pauli's exclusion principle. Option number A. Question number 15. Identify degenerate orbitals from the following for hydrogen atom. If we check the energy level of all the orbitals, as the principal quantum number goes on increasing, its energy of the orbitals will goes on increasing. Here question is asked for the hydrogen atom, which one is the degenerated orbitals. We can consider that degenerated means what? Whatever the orbital is present, that is main shells K, L, M, N, these are the main shells or orbits, and it has the SPDF as the suborbitals, that is number of orbitals. Degenerate orbitals are present in that. Again, that if we take the s orbital, then it has only one orbital. If we take the p orbital, it has the three suborbitals, that is px, py and pz. According to the degenerate orbitals, these all p orbitals which has px, py, pz, these all have the same energy level. S orbital has the same energy level because it has only one orbital. If we take the d orbital, it has how many orbitals? 5 orbitals. All 5 orbitals have the equal energy. That's why these orbitals we can say the degenerate orbitals. Here in case of hydrogen, if we check, 2s and 2p are the degenerated orbitals. That is option number C is correct answer for this. Question number 16. Find the number of orbitals and maximum electrons respectively present in M shell. If we talk about the M shell, then its principal quantum number will become n is equal to 3. And if we calculate its azimuthal quantum numbers, then we will get the three values for that. That is 0, 1 and 2. Then if we talk about the M shell, then how many orbitals are present there? S orbital, P orbital and D orbitals are present. S orbitals, number of S orbitals are present in M shell are 1, and P orbitals, these are 3, and D orbitals are 5. Then if we take the total of these orbitals, how many orbitals we get? 9. According to that, if 9 orbitals are there, then how many electrons they can occupy? They can occupy the 18 electrons. Then 9 orbitals and 18 electrons in that, that is the option number B is correct answer for this question. Question number 17. Find the number of unpaired electrons for the copper in ground state configuration. इस क्वेश्चन में आपको कॉपर के ग्राउंड स्टेट इलेक्ट्रॉनिक कॉन्फ़िगरेशन में अनपेयर्ड इलेक्ट्रॉन्स कितने मिलेंगे, ये क्वेश्चन पूछा है. तो हमें नंबर ऑफ अनपेयर्ड इलेक्ट्रॉन्स वी गॉट 1. दैट इज ऑप्शन नंबर ए इज करेक्ट आंसर फॉर दिस. Question number 18. Which of the following elements has the lowest number of unpaired electrons in ground state? Here options are given: silicon, sulfur, phosphorus and aluminium. We have to take its electronic configurations and which has the unpaired electron in the last orbit, that we have to check which one has the lowest number of unpaired electrons. If we check all the electronic configuration, we got aluminium has the only one electron in its outermost orbit. That's why that option is correct answer for this option number D. Here one new term is there, isoelectronic species. What is isoelectronic species? Means any atoms, ions or molecules that have the same number of electrons in that is called the isoelectronic species. By the name only you can remember electronics, isoelectronics, that according to their number of electrons present in that they are equal. For example, sodium and fluorine. These are the isoelectronic elements, and chlorine and calcium. These also isoelectronic elements. Question number 19. Which of the following species is not isoelectronic with neon? Now if we see the neon has electron number 10. Then we have to check their following options with the number of electrons. If we take first one, oxygen 2 minus. If it is showing the charge minus, it means it accepts the electrons. Oxygen has the atomic number 8. It accepts 2 electrons. It becomes 10 electrons. Sodium no charge given. That's why we have to write their number of atomic number and their electron number is the same. It's 11 electrons are present in the sodium. Then magnesium, if we take, it shows the positive 2 charge. It means it gives out the electrons. That's why it becomes positive charge on that. Then if we check the atomic number of magnesium, it is 12. It gives out 2 electrons. Its number of electrons will become 10. In case of aluminium, it gives out 3 electrons. That's why its atomic number is 13 minus 3 we have to do. We get the 10. Then in the question is asked which species is not isoelectronic with the neon. Means which species, which element is not showing number of electrons as same as of the neon. That is only the answer, sodium atom. It is showing 11 electrons. That's why for this question, if we check the option number B is correct for this. Question number 20. Which from the following element is isoelectronic with sodium? Now here on the sodium plus charge is given. That's why we have to consider it gives out 1 electron. Its atomic number is 11. And we have to minus 1 from that because it gives 1 electron. 1 plus charge means 1 electron given out. Then its number of electrons will become 10. As we check all other elements in the options, then which element have the 10 electrons in that? Only the neon. That's why for this question, option number D is the correct answer. Question number 21. Which of the following pairs is an example of isoelectronic species? Now if we check the option number A, oxygen has 8 electrons and it accepts 2 electron more. It becomes 10 electrons in the oxygen atom. If we go with the sodium plus element, then we can say that it has 11 atomic number and we have to subtract 1 from that because it has 1 positive charge. It becomes 10, means in the oxygen minus 2 and sodium plus 1, it has the same number of electrons. Then this pair is the isoelectronic species. Then option number A is correct answer for this. Question number 22. Which of the following pairs is not isoelectronic? In the options, if we check magnesium and aluminium, it has the 10-10 electrons. Then in second option, sodium and neon also has the 10-10 electrons in that. Then argon and potassium, it has the 18 and 18 electrons. But in the case of iron and magnesium only, it has the 24 and 23 electrons. That's why it is not the isoelectronic pair. That is option number D is correct answer for this. Question number 23. Identify the rule or principle for following statement. Pairing of electron in the orbital belonging to the same subshell does not occur unless each orbital becoming belonging to that subshell has got one electron each. That is the Hund's rule. Only you have to remember all the principles. Then you will get the answer, correct answer for this. Option number B, that is the Hund's rule. Question number 24. What is the designation of an orbital with quantum number n is equal to 4 and L is equal to 3? Here principal quantum number 4 is given and L means azimuthal quantum number 3 is given. As we know that 0 azimuthal quantum number means s orbital, 1 azimuthal quantum number means p orbital. For the d orbital, azimuthal quantum number is 2, and for the f its azimuthal quantum number is 3. Then here L is equal to 3 given, it means 4f. 4 is the principal quantum number and L is equal to 3 means f orbital. Then here option number D is correct answer for this. If we check all options other, 4s, s means L value becomes 0, p means L value will become 1, D means L value will become 2. That's why here L is equal to 3 given. It means it is the f orbital. That's why option number D is correct answer for this. Question number 25. What are the possible values of magnetic quantum number for p orbital? If we see, if s orbital is there, then it represents the zero magnetic quantum number. If we check the p means p is equal to 1 for the azimuthal quantum number, and for the magnetic quantum number, that is becomes -1, 0 and +1. These all values are included into p orbital, that is -1, 0 and +1. If azimuthal quantum number is equal to 2, then what we have to consider? All the values from -2 to +2, that is -2, -1, 0, 1 and 2. All will be included. If d orbital is asked, but here p orbital asked means its azimuthal quantum number L value is 1. Then if 1 is given, then all numbers, that is from -1, 0 and +1, all we have to consider. Then for the magnetic quantum number for p orbital will be 3. That is option number B is correct. Question number 26. Which of the following is a correct set of 4 quantum numbers for the valence electron of radium? If we check the electronic configuration of radium, its valence electron is present in the 5s orbital, that is 5s1. Then we have to take the consideration of 5s1 only for finding out the all quantum numbers, that is principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Here we get the principal quantum number n is equal to 5. By the S we get that its last electron, its valence electron is present in the s orbital. Then its L value, that is azimuthal quantum number, will become 0 because 0 only represents the s orbital. According to that, then magnetic quantum number also becomes 0 because L has 0 value, then M also becomes 0. As only one electron is present in the s orbital, it is only with the positive half. Then if we check all options, then from that we will get the option number C is correct answer for this. Question number 27. What is the number of electrons present in sub D energy level in +2 state if its atomic number is 30? If we check the atomic number 30, it is of zinc. Then if we check the electronic configuration of Zn plus 2, it becomes 3d10 and 4s0 because it accepts the 2 more electrons, and that 2 electrons will be filled in the d orbital because it has the more energy, that d orbital has the more energy than the 4s orbital. That's why here in the d orbital how many electrons are present it is asked, then option number B is correct answer for this. 10 electrons will be present in the d orbital. Question number 28. Which of the following is not true regarding particle nature of electromagnetic radiation? Then option number A is quantum theory explained black body radiations. Option number B, the energy of electromagnetic radiation depends upon the frequency. Option number C, speed of the electromagnetic radiation in vacuum is 3 into 10 raised to 10 meter per second. Option number D, smallest quantity of energy absorbed or emitted is in the form of quantum. If we check all the options, option number C is correct answer for this. The velocity of all type of electromagnetic radiations is the same and it is equal to the velocity of light. However, they may have the different wavelengths and frequencies. Question number 29. Which among the following is ground state electronic configuration of fluorine by orbital diagram method? Here we know electronic configuration of fluorine is 1s2, 2s2, 2p, 5. In the p orbital there should be 5 electrons with opposite spins. Now if we check options, in option number A, in 2p only 3 electrons are there. In p also same 2p, 3 electrons are there. If we check the C option, there are 5 electrons and it is that electrons also drawn in correct way, that is with the opposite spin. It is filled. It is the correct option. And if we check the option number D, 6 electrons are filled in the 2p orbital. That's why that is also not the correct orbital diagram method for the fluorine. That's why option number C is correct answer for this. Question number 30. Which of the following equation relates energy E of orbit to its principal quantum number? Here option number A is correct. E is equal to minus RH into 1 by m square. That is the direct formula asked. Option number A is the correct answer for this. Question number 31. Which of the following is correct statement regarding wave particles duality of electromagnetic radiation? Option A. Black body radiation can be explained by wave nature of light. Option number B. Photoelectric effect could not be explained by wave nature of light. Option number C. When light interacts with matter, it behaves as an electromagnetic wave. Option number D. When light propagates, it behaves as a stream of particles called photons. From these all options, option number B is correct for this, because the black body radiations or photoelectric effect could not be explained by the wave nature of light. When light interacts with the matter, it behaves as a stream of particles, and when light propagates, it behaves as an electromagnetic wave. Then from these all options, option number B is the correct answer for this. Question number 32. Identify the correct increasing order of energy of orbitals. If we check the energies of 4f, 4p and 6p and 6d orbitals in the first option, it is the correct option, because if we check 4f and 6p, then it has the same number of electrons in that. But we have to check the principal quantum number, which has the more principal quantum number, it has the more energy. Then option number A is correct for that. If we check the B option, its p orbital is written first and d orbital is next, and then 4f orbital written, because that 4f has the lower energy than the 6p. That is the wrong option. Then 4f, 6d and 6p. Then again here it is swipe of d orbital and p orbital, which one is the wrong only. Then 6d, 4f and 6p, that is also wrong option. For this question, only option number A is correct. Question number 34. Which of the following orbitals have the same value of n plus L as that of 3d orbital? Here n plus L for the 3d, it will become 3 means principal quantum number, that is represented by the n, and d means suborbital, that is L. D value has 2. Then it total n plus L becomes 5. Then we have to check the options for the 5. Its total become for the n plus L. If we check for the 4s, n becomes 4, s becomes 0. its total value becomes 4. That is not the correct option. We want the total 5. Then if we check with the 3s, 3 plus 0, it becomes 3. Then if we check 4 plus p, 4p, then 4 is the principal quantum number, and for the p orbital value is 1. 4 plus 1, it becomes 5, which is the equal to the 3d orbital's value. Then here n plus L value for the 4p orbital and 3d orbital is the same only. That's why option number C is correct for this. Question number 35. Identify the orbital having the lowest energy from the following. As I have explained already, we have to check with only the principal quantum number, which is the highest principal quantum number, highest the energy, lowest principal quantum number, lowest the energy. In this question, it is asked lowest energy which one has from the following. If we check with the principal quantum numbers, 2 is the lowest principal quantum number. Here then we can say that 2p has the lowest energy. It is option number A. Question number 36. Which of the following orbitals is represented by n is equal to 3 and L is equal to 2? Now here we get that n is equal to 3 means what? Principal quantum number. If we check all the options, it have the 3 only. It is fixed that 3 is the principal quantum number. Now the case is that L is equal to 2 given. It means we have to find out which subshell is there. As we know that 0 means S subshell, then 1 means P orbital, then 3 means D orbital, and 4 means F orbital. Here we have we took the L is equal to 2, then 0 S, 1 P, 2 D. It means L is equal to 2 means D orbital. Then we can check that which principal quantum number is combined with the D orbital. It is option number C is correct answer for this. 3D orbital it represents. Question number 37. Identify the orbital having highest energy from the following. Options are given 2p, 3s, 3d, 4p. Here we have to just watch the principal quantum number. Whatever the principal quantum number, if it is more, then higher is the energy of that orbitals. Here we can see 4 is the higher principal quantum number among all options. Then directly we can write 4p has the highest energy. Question number 38. What is the total number of orbitals present in n shell? Now here orbital and orbital is the different term. Whatever the principal quantum number n is equal to 4 given, it is the orbit. Number of orbits 4 are there. And orbitals means suborbit like SPDF orbitals. If we check with the n is equal to 4, we have to write their azimuthal quantum numbers. L is equal to 0, L is equal to 1, L is equal to 2 and L is equal to 3. Means how many values we get for the azimuthal quantum number? 4 values. Azimuthal quantum number, it is nothing but the shape of the orbital. Which kind of shapes are present in of the orbital it is given. SPDF orbitals are present in that. If we check with the suborbitals of that, in the S only one orbital is there, in P 3 are there, in D 5 are there, and in F 7 orbitals are there. We have to add these all orbitals and we have to calculate the number of orbitals present in N shell. Then here we got the number 16. For that one shortcut is also there. Whatever the number of principal quantum number given, just we have to do the square of that number, then we will get the number of orbitals. Here 4 is given. If we do the square of 4, it becomes 16. Then number of orbitals in the N shell, directly answer we can calculate. It is 16. Option number D is correct for this. Question number 39. Which of the following species contain 20 electrons? As you can see in the table, potassium plus 1 charge it has. Then its atomic number is 19. If we subtract 1 from that, it becomes 18. calcium 20, magnesium 12, chlorine 17. Then in the question it is asked which species contain 20 electrons, that is option number B, calcium. It is the correct answer for this.